Okay, this is chapter 6, Energy and Matter, homework assignment. Question number 1. So as you can see from this spectrum on the left-hand side, that's radio frequency or radio waves region, and then microwaves, then IR, which is the infrared, then visible region. Again, that's a very narrow range, as I mentioned in the class. And then after that, you should have UV or ultraviolet, and then comes to X-ray. Then on the very far right-hand side, that's the gamma rays, okay? So question A, 1A, which one of those electromagnetic radiation has the highest frequency? Okay, look at this bottom x-axis, this scale, that's frequency. And from the left, 10 to the 8th power, all the way to 10 to the 21st power. So therefore, we can say from left to right, frequency increases. All right? So therefore, gamma rays should have the highest frequency, which is this one is the correct answer. And then the next one, which one has the highest energy? We already learned energy is directly proportional to frequency. So therefore, from left to right, since frequency goes up, energy also goes up, which means again gamma rays should have the highest energy. So that should be this choice right here. That's for 1B. 1C, which one has the longest wavelength? So we'll go to top again. And here, obviously, the wavelength from the left-hand side, that's the longest, 10 meters. To the right-hand side, that's 10 to negative 13. Obviously, the longest one should be in this region, which is the radio waves. So let's find out the answer. Radio waves, that should be right here. That's question number 1. So this is question number 2. And A have a radio station found at 102.4 on the FM dial broadcasts at a frequency of 1.024 times 10 to the 8th hertz. What is the wavelength of these radio waves in meters? Okay, what do we know? We already know wavelength, frequency. Okay, and what do we need to find out? We need to find out wavelength. Okay, so we know frequency, we just need to find out wavelength. And in this case, of course, you have to use the key equation, which is C equals lambda nu. Okay, and now we know C, which is constant, should be given. We know nu, which is frequency. Then we can just derive this equation, C over nu. And C is 3 times 10 to the 8th meters per second. All right. Okay. And now on the bottom, the frequency. Frequency is, we convert, you see it's right here, 1.024 times 10 to the 8th, and that's 1 over second. You see the 1 over second right here, cancelled with the 1 over second here. So then we should have meter as the unit for the final answer. Okay, so the final answer should be meters, and that's exactly what is asked. What's the wavelength in meters? Okay, so we just get the number from your calculator. most likely you are going to have 96,238. And from the question, we know we need to keep 4 sig figs, which means this is the last one, the last digit in a sig fig. And then we just do the rounding. That should give us 2.962 meters. So the wavelength emitted from this radio station having a frequency of this much should have a wavelength of about 3 meters. So that's question number 2. Question number 3. Okay, let's first analyze this question. So what do we know? We know there is a radiation and it has a wavelength of 435.8 nanometers. Okay, so we know the wavelength. Let's just mark it. Then we need to find out the energy in joules that is related by 1 electron in a mercury atom to produce a photon of this light. So really, what's important in this question in order to solve it is really, okay, what's given? Lambda is given. And what do you need to find out? Energy in joules. Okay. So remember, light or radiation behaves both as waves and particles. So as waves, C equals lambda nu. And then from this equation, we should be able to find out, because we know lambda in this case. So then we need to find out, we know lambda. We need to find out frequency equals C over lambda. So that's the wave nature of radiation or of light. So now the particle nature, E equals h nu. Is that right? So E equals h nu, and then nu equals C over lambda. So therefore, we can rewrite this. E equals h C over lambda. Now let's analyze the last equation right here. So we need to find out the energy. Okay, so that's what we have on the left-hand side. On the right-hand side, we do know the value for Planck constant h. We do know the speed of light, c, in here, even though they are not given in the problem, but there must be given actually when you take tests or when you work on such problems. And then the only other piece of information we need is wavelength, which is given as well. So therefore, we will just use this equation to work on this problem. So E equals, what is h? 6.626 times 10 to negative 34th joules second. And now, what is C? 3 10 to the 8th meter per second. And now the lambda is given right here for 135.8. That's nanometers. You see, we have a problem. So now, well, we can cancel the second and second here, but you see meters and nanometers, they cannot cancel each other. we have to convert. Again, converting from nanometers, we'll put nanometers on bottom, and converting to meters so that we can cancel those 2 meters right there. 10 to negative 9. Okay? So this way, meters can be cancelled. And now, nanometers also cancel. So what is left? It's only this unit, joule, is left. So that should be the unit for the final answer. I'll put that in there. Okay, from your calculator, if you do that correctly, you should have 4.8063. So the last digit in the sig fig should be the third decimal places. So why 4 sig figs? You see here? That's 4 sig figs. Okay? And then what you can do next is, of course, you will just complete this calculation. Okay, so that's what you have in there. And next one, you just do the roundup. 4.806 times 10 to negative 19, and that should give you the unit as a joule. So therefore, this is the answer for what is asked. You know, what is the amount of energy in joules? So that's question number 3. So now this is question number 4. Okay, see what we know. We know one of the line spectrum is at wavelength of 7.8 times 10 to negative 7 meter. And of course, we have another one, but we'll do the first one first, okay? What are the frequencies of those 2 lines? So basically, we already know lambda. We just need to find out the mu, okay? And we just simply use, again, the key equation here should be C equals lambda over nu. And from there, we can say, okay, nu equals C over lambda, all right? So C is the speed of light. So we will just say 10 to the 8th meter per second. And then over lambda. So lambda in this case is given in meters. That simplifies the calculation, and that's meter. And now, as you can see, the meter on top and the meter on bottom, they can be cancelled. So therefore, the final answer, what we have, should have a unit of 1 over s, so which is the frequencies unit. And that should be 3.843 times 10 to the 14th. And so now let's fix the sig figs. That should be 2 sig figs. Why? Because you can see right here, that's just 2 sig fig. So therefore, if it's 2 sig fig, we do the roundup, then that should give us 3.8 times 10 to the 14th. That's frequency for the wavelength at 7.8 times 10 to negative 7 meter. So that's basically A. Okay, and now B, you just do the same thing. So just instead of using this wavelength, you just use this wavelength. All right, so let's do that. That's the first one. This one is A, and now let's work on B. Put that right here. Mu equals C over lambda meter over a second. And now, so the wavelength is 4.2 times 10 to negative 7 meters. So again, meters are cancelled. And now we should have 7.138. 7.138. Again, I underline the last digit in the sig fig, and that's 1 over s. So again, do the round up. That's 3. We can just simply drop that digit and the ones after that. So that should be 7. Oh, I need to. Actually, there should be also 10 to the 14th. 7.1 times 10 to the 14th. Okay, so 7.1 times 10 to the 14th hertz. So that should be the answer. Can you see it? Okay, now you see everything. Yeah, that's the final answer for B. That's question number 4. Okay, this is number 5. Question number 5. One of the radiographic devices used in a dentist's office emits an X-ray of wavelength 2.093 times 10 to negative 11 meters. We need to find out the energy in joules and the frequency in 1 over s, which is hertz. Okay, so first let's find out the frequency. Okay, let's find out the frequency first. We can simply use this equation you are already familiar with, C over lambda, all right? And then it's meter per second. And then the wavelength is already given in the problem, all right? So it's already there. We just copy that number. So since it's already in meters, the wavelength, that can cancel the meter in the speed of light, all right? So now we should have s, 1 over s, as the unit for the final answer in this step. So that is also exactly what is asked. The frequency in hertz, so 1 over s is the same as hertz, okay? So your calculator should give you 505. Okay, 4 sig figs if you count. So therefore I underline the last digit, and then that's 7. We round it up. Oh, that should be 1.506 hertz. Oh, actually, again, times, don't forget the 10 to the 19th power. Okay. So that's the frequency, energy, the other key equation in this chapter, h nu. And h is a Planck constant. So the units for Planck constant is joule second. Now times the frequency we just calculated. Note that I didn't use 1.506, I used 1.50574, the original one, because in this step, this answer is not the final answer. It's only intermediate answers, all right? So that's why I will not using the round up values. So that would give me a better calculation accuracy. Times 10 to, that's positive 19. And again, that's 1 over s. As you can see now, s and s are cancelled. So the final answer should carry unit of joule. And that should. Again, 466. And that should, we can approximate that after dropping the last 2 digits. So that should be, no, actually again, we can't afford of forgetting the 10 to negative 15th power times 10 to negative 15th power joules. Okay, so that's it. That's for all the 5 questions in chapter 6, energy and matters, homework assignment.